Okay, so welcome back. We're going to have a look at the beginning of the new topic, which is energy. You will find in the folder this video, you will find two sheets. One's a worksheet and one is a summary of this video. If you don't have a printer, you don't have to print it out. You can just take the notes in the form that I've given you in the sheet. And we're going to learn some new things about this word here on the screen, energy. Okay, so energy is quite a difficult concept to understand because its definition, which is the ability to do work, doesn't really mean anything to us at the moment. Okay, so I'm going to try and break it down a little bit, but we can think of energy as being something that allows things to happen. Now, energy exists in 5 stores at this level. Now, there are other stores, and you will probably hear about them if you look on revision websites and things, but actually you only need to know about 5 particular stores of energy. Okay, now there's 2 words here. There's stores, which we can kind of think of as where the energy kind of is kept. And then there's this other word, transfers. So energy is transferred from one store to another store. Okay, so for example, I'll give you an example in a minute once we get to the point where we understand what we mean. But stores is where it's kind of staying in that particular energy form. And then transfer is where it changes from one to another store. Okay, and we have a new unit. So the unit for energy is the joule, or J if we're just putting a number with the letter to show the unit. It's J. So stored energy is measured in joules. And because we can measure energy, it has a quantity, always has a number attached to it. So we can say 10 joules of energy, or you could say 100 joules of energy. So it is a measurable quantity. Right, so let's have a look at what these 5 energy stores are. Okay, so the first is thermal energy. So this is energy that is stored in objects which have heat. So the hotter the object, the more energy is stored in the object. So if you were to heat something up, then you are filling the energy store. You can think of energy stores kind of like little buckets of energy. So if you've got thermal energy and you fill the bucket, you're storing more energy. So the way you fill the thermal energy bucket is by heating something up. Then we've got chemical energy. Chemical energy is the energy that is stored in 2 things, either a fuel like coal or oil or gas, or stored in the in food. Okay, so if you were to eat a dairy milk or an Easter egg, you are going to be consuming chemical energy. Okay, then we've got kinetic energy. Kinetic energy is the energy of a moving object. Okay, so to fill up the energy bucket for kinetic energy, we would need to speed something up. And then as something slows down, we are losing, we are emptying the kinetic energy store. And we've got gravitational potential energy. So we've met the word gravity quite a lot in the forces topic. We are kind of aware of what gravity is. So the potential is kind of the potential for something to happen. Okay, so gravitational potential is the kind of amount of energy stored by going higher up. Okay, so if I put a book on the table, it has potential energy. It has the gravity is pulling it down by a certain amount, and it has the potential to, if I took the table away, to fall down. Okay, so the higher something is, the more gravitational potential energy, and we can call that GPE. And lastly, we've got another form of potential energy called elastic potential energy, and this is the energy that is stored in a spring that has been stretched or something that has been squashed. Okay, so it's got an energy store there, and we can transfer, as I said, between these different stores. However, energy cannot be made. It was all made originally in the Big Bang. There's the same amount of energy in the universe now as there was at the Big Bang, and we haven't lost any. Okay, so we can't make any more. We also can't destroy it. All you can do with energy is move it between the energy stores. Okay, and when we do that, we call that transferring. Okay, so for example, if I had some chemical energy in a fuel, let's say a piece of coal, and I set it on fire, then what I'm going to do is I'm going to transfer that chemical energy that was in the coal to thermal energy, okay? And it's going to be released into the environment, and we call that dissipated, okay? Dissipated. Right, so let's have a look at each of these in more detail. So thermal energy store, a hot cup of tea has more thermal energy than a cold cup of tea, and that is because there is more heat in the hot cup of tea compared to the cold one. Okay, now we fill the energy store, as I said, when something is heated up. So if I wanted to make my cold cup of tea have more thermal energy, then I would need to heat up that cup of tea. And in doing so, I'm going to have to transfer energy from somewhere else, like gas on the hob or electricity from the kettle. But there is definitely going to have to be an input of energy in order to increase the thermal energy. Chemical energy, I said food or fuel. So here's an example. A piece of wood has more chemical energy than after it's been burnt. Okay, so before I burn the piece of wood, all of that chemical energy is stored in it. But as soon as I start to burn it, I'm going to be transferring that energy via thermal energy to the surroundings. I'm going to dissipate the energy. And you can see at the bottom, a chemical energy store is emptied during some reactions. Okay, I'm going to get onto that a little bit more later. Then we've got kinetic energy. Now, it's a bit of an odd one because we don't necessarily think of it as being a store if something is moving, but in fact it is. So a moving car has more kinetic energy than a car that is waiting in traffic, one that is not moving. A kinetic energy store is filled when an object speeds up. So if I start a car and then I start driving and I get faster and faster and faster, I'm increasing the kinetic energy store. I'm filling the bucket. I'm filling the kinetic energy store. And in doing so, I'm going to be taking that energy, transferring it from another place, probably a chemical store in the petrol or the diesel. So you can see there's these kind of big stores, but then it's always moving between them, and we don't really fully know what energy actually is. It's a very abstract concept. We can't really describe what it is, but we can see the effects of it and we can measure how much there is. Okay, gravitational potential then. An object at height has more gravitational potential energy than one on the ground. So the higher you lift something up, the more gravitational potential you are going to be getting. Okay, so if you go up a mountain, you've got more gravitational potential energy at the top. You filled the gravitational potential store, compared to if you start coming down the mountain, where you're going to be emptying the gravitational potential energy store. Okay. And lastly, here is our elastic band. If you stretch it, and I'm sure you know this, I'm sure you've done this, if you stretch it, you put more energy into it. If you then let it go, you're going to transfer that energy into movement, into the kinetic energy, and the band will move. Okay, so you're going to build up the store, you're going to stretch or squash something in order to fill the store, and when you let go, you start to empty the store, it gets transferred to somewhere else, usually movement in this case. Okay, so let's have a quick look at some examples. So thermal store, you can see here there's two boxes. This one on here is when the store is empty. This one over here is where the store is full, and you can see you can move from empty to full or from full to empty. Okay, so a substance with molecules with more vibrations, such as a kettle heating up, the temperature increases, therefore the thermal store increases. Okay, so getting hotter this way, whereas if we're going back this way, if we're emptying the store, a substance with molecules vibrating less, such as the liquid in a radiator cooling down, the temperature decreases, and therefore the thermal energy store also decreases. Okay, then chemical store, energy from atoms and molecules combining or joining together. Now, we haven't done a huge amount of this. We did talk a little bit about making new substances in the particles topic, but we're going to talk a little bit about photosynthesis now. So we've got the emptier chemical store. If a plant stores energy when it turns carbon dioxide and water into sugars and oxygen, that is the photosynthesis bit that we were talking about, making sugar, making glucose, making oxygen. What you're doing is you're combining the little molecules of carbon dioxide and water. And if you remember, some of you might remember, I said that glucose was C6H12O6. So where did we get those from? We got them from the carbon dioxide and water. We added them together, we joined the molecules together, and we've increased the chemical energy. We've gone towards filling the store. If we do the opposite, if we break down those molecules, so for example in a fuel, if we start to burn it, what we end up doing is we end up breaking it down and making carbon dioxide and water, and we end up making the store less. Okay, the store goes down of chemical energy because we've released that energy as something else. If we're burning, it's going to be as thermal energy, as well as some other types of energy which aren't necessarily stores themselves, things like light, things like sound as well. Okay, it all gets dissipated to the environment. Here's our kinetic, so energy from moving objects. So as we said, getting faster, pedaling on a bike, we're going to be increasing the kinetic energy store. And if we are slowing down, such as a boat coming to a stop, then we are going to be decreasing or emptying the kinetic energy store. Okay, and obviously if we're emptying it, then it must be going somewhere else. It doesn't just disappear. Gravitational, we've got energy from moving an object towards or away from a planet's surface. Okay, so it doesn't have to be Earth. I have only talked about Earth, but it could be any planet. Okay, so an object falling towards a planet's surface, such as a ball falling to the ground, we started with a lot of potential because it was high up, it's falling towards the ground, going nearer to the surface. We're emptying the store, so we're going to a more empty store. And if you are moving it away from the planet's surface, you're taking it up, water being pumped uphill to a reservoir, or walking up a mountain or anything like that. You're moving away from the surface, the sea level, then you are going to have more gravitational potential energy, so you have made your store more full. And lastly, elastic store, stretched or squeezed. It doesn't have to be stretched, so you can stretch a spring, but you might also squeeze something together like a sponge or something that compresses, and then you're able to release it and it will usually spring back again. So it might well transfer to kinetic energy. But we've got a material which is going back to its original shape, such as a rubber band relaxing or a car tire letting air out. That is going to be reducing the elastic potential, and so therefore we go to the we're emptying the store. If we go the other way, if we are stretching or squeezing, then we're going to be filling the store. So you've got to think of this kind of bucket system. It's like quite a complex model of different buckets, and you're kind of tipping things from one to another. So the energy, let's imagine we had 5 buckets. You can tip the same amount of water between all 5 buckets. Okay, but you would never get rid of the water. So in that analogy, water would be the energy. Okay, and it can be moved around between stores, but we don't lose any energy when we do that. Okay. So it's quite useful for us because we obviously use energy a lot for all sorts of things in our lives. So it's very useful to be able to transfer energy between these different stores. Okay, so here's an example for you. Chemical energy stored in food is transferred to thermal energy store and kinetic energy store by our bodies. What that means is keeps us warm, and it means we can walk around, okay? But without the original thing, the chemical energy, we wouldn't have any energy to be able to do those things, okay? So it's really important that we're eating food, providing us with chemical energy in order for us to do keep warm and move around and do all the other 7 life processes. Then gravitational potential energy stored in a ball is transferred to kinetic energy when it falls to the ground. So if you hold a ball up and you hold it still and then you drop it, it's going to fall, it's going to move to the ground, and all that gravitational potential energy is transferred into kinetic energy as it moves. So when it hits the ground again and stops, then that kinetic energy has gone. Okay, it's been transferred somewhere else, likely to be in the kind of sound, a little bit of heat as it hit the floor, not that you'd be able to notice it, but that is the end of that transfer. Okay, and as I said, you always end up with energy lost, dissipated to the environment. Okay, so you can have a little think about what other energy transfers you can think of. I'm going to allow you to pause the video. So just pause, see if you can write down, let's say, 3 examples of other things that you might be able to think of from your everyday life. Okay, you can see these on the sheet as well. You don't need to print off the sheet. You can just write them down in your book if you want to. So what are the energy transfers when you are dropping a ball from a height, you're riding a bike, you're turning on a gas cooker, and a car is moving? So the energy transfers, what's happening to the energy. Okay, pause the video and have a go at that. Okay, right, so I'm going to go through the answers, so hopefully you've had time to do those. So number 1, dropping a ball from a height. Well, at the beginning it's going to have gravitational potential energy, and then it is going to transfer to kinetic energy. It's going to move, fall down. Okay, so the way I would write that is I would write GPE for gravitational potential energy, then I'd write a little arrow, and then I'd write KE for kinetic energy. It's gone from gravitational potential energy to kinetic energy. Right, riding a bike. Presumably you've just got on the bike, so you're just about to start pedaling. So you are going to get chemical energy from your food, and you're going to transfer that by pedaling to kinetic energy. So I would write that chemical arrow KE for kinetic energy. Number 3, turning on a gas cooker. Okay, so again, the gas itself is a fuel, so it's going to start as chemical energy and it's going to transfer to thermal energy, because that is the heat being given off when you burn the gas, okay, and allowing you to cook whatever it is that you want to. And then a car moving, so it doesn't tell us a lot about this. So if it's speeding up, then it could just be increasing the kinetic energy store. But I think it's probably getting at the kinetic energy store. We are going to get some thermal energy with friction from the road to the tyres. We're probably going to get some sound energy as well. Now, sound energy, again, is a way of dissipating. It's a type of energy you can dissipate as, but you wouldn't really call it a store of energy, a bit like light as well. Okay, so that one's a little bit more confusing. Right, now if you open the second document that I've given to you, so not the notes one, the other one, I think I've called it Science Day, I think it's Lesson 2 Science Part 2. You will find both this and this to have a go at. Okay, so once you've watched this video, once you've paused and filled in or made notes on the video using the structure that I've given you in document part 1, have a go at doing these. Now again, you don't have to print them off or anything, you can just write them down, but I would like you to write the sentences as well. So say what this one is: stored by objects that are moving. What type of energy is this? What store is it? Stored by foods and fuels. So you can write whatever it is, then the sentence to make 5 sentences. And then I would like you also to write this down at the top. It's a quantity. It can be measured in numbers, which I've already said to you. You can put numbers in front of that joules. It's a measurable quantity. And then secondly, where it says task 1, but it's actually task 3 or something, isn't it? I'd like you to try and write these sentences out. So again, you can find them in document 2, or you can pause the video and do them from here if you want to. So a moving bicycle stores kinetic energy because it is traveling along, it's moving, okay? And you do all the rest as well, okay? That is what I'd like you to do. Thank you very much. much. Now, how do I get out of this? Good luck. Send me some questions if you are getting stuck via email, please.